Okay, this is the P4 paper from June 2022. It's question number 6. As we can see, this is a vectors question. We're going to be doing some work solving geometrical problems in 3D. You can see we've got 3 dimensions here. The idea about the fact that we've got perpendicular lines means we'll be using the scalar products, and we've got to work out the vector equation of a line for that part there. So let's just go ahead and make a start to it. So with these vector questions then, it tells me A is wherever it is, B is wherever it is, and C is wherever it is. What I need to do is to do a quick representation of that so that I can then work out what I'm doing. So this doesn't need to be an accurate sketch, but if I've got a situation, I know this is in 3D, but I can't draw in 3D, neither can you. So all I'm going to do is I'm just going to say A's here, B's here, and C's here. So I've got A, B, and C there at those points, and now I can start reading through it. It says the line L passes through A and B, so it passes through that line there. Find the vector equation of that line. Right, well now I can do that, so now I can see what I've got to do. If I want to work out the vector equation of a line, the vector equation of a line is R equals, doesn't matter which letters you use, P plus lambda Q, for example. P is the vector that gets me onto the line, and then Q is actually going up and down the line, is going to be the vector AB in this case, but it's going to be parallel to the line. So what I need to do to work out any vector equation of any line is to say, get onto the line and then go up and down the line. Now I don't need to get onto the line at A, I could have got onto the line at B and then gone up and down the line. So when I'm working this out, this could be vector OA or OB, but this really doesn't have a choice, that's going to be the vector AB. So what that means now is I know exactly what I'm going to do, it's just a matter of actually going ahead and doing it. So I keep the diagram on there, keep the diagram just because that might be needed for further work with it. But if I'm going to say over here, in order to work out the equation of a vector equation of a line for L, R is equal to P plus lambda Q. So in other words, I'm going to do it as R, as R equals the vector OA plus lambda lots of AB. So I'm just going to explain what I'm doing there, and now I'm going to work out those bits. So if I'm going to work out AB always, I'm just going to do this really quickly, but you should absolutely know this. So I shouldn't need to be drawing out these little bits here. If I want to do AB, I want to go from there to there, it is minus A plus B. Minus A plus B, if I consider, which I do for any of these vectors, that the vector OA is little a, the vector OB is little b, the vector OC is little c. So AB is going to be B minus A, which now, writing down the points, but in vector format, I like to use column vectors. You could use I's, J's and K's, got no problem with you doing it, but I'm going to stick with what I find easiest to do. So I'm going to write this as 5, 3, 2, 5, 3 minus 2, I just checked, 5, 3 minus 2 minus the other vector, which is 1 minus 4, 3. Now, as I say, I could do every single question in I's and J's and columns, but the videos get too long, so you're going to bear with me. I'm doing it as a column vector. I think it's easiest to do it like that. So that makes the vector 4, 7, minus 5. So now if I want to write down my vector equation, R is going to be equal to OA, which is 1 minus 4, 3, plus lambda lots of AB, which is 4, 7, minus 5. Again, as I just alluded to really early on, you could have taken OB as your start-off point and then had plus lambda lots of AB. It would still be the same, just an alternative version of the equation of that line there. Understanding that this is a point on the line and this is the direction of the line, and we're going to use that in the second part when we're looking at it. We're going to use that for the second part. So, what does part B say? Part B says Given that AC is perpendicular to L, so if AC is perpendicular to L, what I've really got is a new diagram now. And I am going to draw it out, a new diagram. If I was being clever, I'd have done this first off, but I don't think it's fair on you guys that I could know what this diagram would look like. So this is what I would do in the exam. They're telling me now that AB is perpendicular, sorry, that L is perpendicular to AC. So my diagram really needs to look more like this. A is here, B is here, and C has got to be down there. Make a proper right angle. We've got this situation. If that's A and B, C is perpendicular to it. So we've actually got that it's at 90 degrees there, if I'm trying to work that one out. And it says, okay, given that AC is perpendicular to L, can we find the value of P, which I'll show you how to do that, and then hence can we find the area of this triangle ABC, and we'll do that in a second. But let's first of all focus on the fact that AC is perpendicular to L. Okay, part B. If two vectors are perpendicular to each other, in this case our vectors are AC and AB, if they're perpendicular to each other, then we know that the dot product of them will be equal to 0, okay? So when I'm working out this one, AB there, that is the direction of the line, as we said previously, that's why it's highlighted in blue. So if I'm going to do this, I haven't got AC yet, let's find AC. So AC is C minus A, which would be 3P minus 1 minus A, you had A already, 1 minus 4, 3. Okay, so let's tidy it up and see what that comes to. So 3 minus 1 is 2, P minus 4, that's going to be P plus 4, and minus 1 minus 3 is that. So AC is that, and we can now say that AC dot AB is equal to 0. So actually, if I was doing this properly, I'm going to write that there and say that AC dot AB is going to be equal to 0, and we've got both of them. So 2P plus 4 minus 4 dotted with AB, which we had already, 4, 7 minus 5. If they're perpendicular, then that's equal to 0. So now I'll be able to work out what P is. So 2 times 4 is 8, plus 7 times P plus 4, plus minus 4 times minus 5, which is plus 20, is equal to 0. We just got to rearrange all that. So that's 7P plus 28 plus 20 plus 8 equals 0. So 7P is going to be equal to minus 56. Okay, so P works out to be equal to minus 8. Pretty happy with that. As long as P works out to be a constant, then you can't absolutely guarantee it, but I'm hoping that I've got that part right then. Hence, find the area of the triangle ABC, giving your answer inserted in its simplest form. Okay, well, because it's a right angle triangle, I'm actually just going to do the length of AC, the length of AB, and I'm just going to do half base times height. So what I've got to do is to work out the length of AC and the length of AB, and then we should be all over this question. So part C, AC was 2P plus 4 minus 4, but we now know that P is equal to minus 8, so that's 2 minus 4 minus 4. And then what I've got to do is to find the length of AC. So the length of AC is equal to the square root of 2 squared minus 4 squared minus 4 squared. And whatever that works out to be, well, it actually works out to be 6. Okay, that's nice. The length of AB is equal to the square root of 4 squared plus 7 squared plus 5 squared. That works out to be root 90, and root 90 is 3 root 10. So the area of the triangle, just checking to see if I found this base there, the area of ABC is going to equal to half base times height, is going to be a half 6 times 3 root 10, which actually works out to be 9 root 10 as the final answer. Okay, so that's a nice question. Hopefully that all makes sense to you and is fairly straightforward.